In this video, we are looking at light and colour. Each colour in the visible part of the spectrum has its own frequency. Stars and filament lamps, for example, emit a continuous range of frequencies across the visible spectrum and are examples of white light sources. A laser, on the other hand, will emit a very narrow frequency range of visible light. A colour filter works by only allowing certain frequencies to pass through and absorbing all the others. In this example, red light passes through and so it is a red filter. Notice how all the other colours are being absorbed. You need to know about the three primary colours in the RGB model. These are red, green and blue. These primary colours can be added together to make secondary colours. Red and blue make magenta, green and blue make cyan, and green and red make yellow. Red, green and blue all together make white, which can be seen in the centre. You do need to learn this, so I'm going to give you 15 seconds to study it. Maybe try and find an easy way to remember it. Then we're going to have a quiz before we move any further. Name the three primary colours. What two primary colours make magenta? What two primary colours make yellow? What two primary colours make cyan? And what colour do red and blue make? There are also three key words you must learn: transparent, translucent, and opaque. A transparent material is a material that transmits all light that is incident on it. No light is absorbed, and so all light passes through. You can see a clear image through it. A translucent material is a material that transmits most light that is incident on it, but the light is scattered. This is due to many internal boundaries refracting the light, and you cannot see a clear image through it. An opaque material is a material that absorbs or reflects all of the light that is incident on it. You cannot see through it. So now let's look at surfaces and colour. The colour of an opaque object depends on chemicals in it called pigments. A white surface has no pigments, and so under white light from the sun, it will reflect all frequencies and appear white. Pigments absorb specific frequencies of light and strongly reflect others. This is a green object where the pigments are absorbing all colours or frequencies of visible light except green, which it is reflecting. If an object of one colour, for example green, is observed under light of another colour, for example red, the object would appear black. Why do you think this is? If you're aiming for an 8 or a 9, you need to start thinking about secondary colours. The secondary colour will only reflect the two colours that make it. What colour will these appear in these diagrams? What if magenta light was incident on a blue object? And what if magenta light was incident on a green object? What colour would these objects appear?